Hello, so in today's class we will see a few more problems using pigeonhole principle. So the first question is, so you are given a set of 5 positive integers a1, a2, a3, a4, a5. Then we need to show that for any permutation ai1, ai2, etc. ai5 of a, the product ai1 minus a1, ai2 minus a2, etc. ai5 minus a5 is always even. So we are given a set of 5 positive integers, and this is any arbitrary permutation of the given set A. Then we are asked to show that this product is always even. Now, in order to show that the product is even, it is enough to show that one of these differences, ഏതെങ്കിലും ഒരു aik minus ak is even. So if one of these differences is even, then we can say that the product is even. Now this is even only if both difference ആണ്, difference even ആണെങ്കിൽ ആവണമെങ്കിൽ ഒന്നെങ്കിൽ രണ്ടും even ആവണം, അല്ലെങ്കിൽ രണ്ടും odd ആവണം. So here we will be using pigeonhole principle. For that, here the boxes will be considered as even, and one for even numbers and one for the odd numbers. So let us look at what happens. Okay, so let us write that much. So to show that the product is even, so it suffices to show the existence of an even factor, say aik minus ak. So it is enough to show that one of the factors is even. Now aik minus ak is even only if aik and ak are even or both are odd. So this is what we need to show. So it is enough to show that either both are even or either both are odd. So therefore we create two boxes, one for even numbers and one for odd numbers. So the number of boxes is equal to 2, and we have cardinality of A equal to 5. So now let us use pigeonhole principle. Now by pigeonhole principle, so if you take 2 into 2 plus 1, so that is equal to 5. So you have kn plus 1 equal to 5. Okay, so therefore by pigeonhole principle there must be at least k plus 1 objects in one of the boxes. That means there must be at least 3 elements. Okay, in the value 2 in, so there must be at least 3 elements in one of the box. So we have n equal to 2 and k equal to 2. So therefore there is at least 3 elements in one of the box. So that is there are 3 elements which are either even which are either odd. So let us take the 3 elements to be, say, AI1, AI2, AI3. Okay. So there are at least 3 elements in one of the box. So that is, there are 3 elements which are of the same parity. That means all are even or all are odd. Let A1, A2, A3 be these 3 elements. So these are the elements which are of the same parity. And now consider AI1, AI2, AI3 intersection A1, A2, A3. Now this intersection is not equal to 5. Okay. So കാരണം നമുക്ക് 3 values ഉണ്ട്. Total 5 values ഉള്ളൂ. 5 values ഞാൻ I have taken 2 sets of 3 values. Okay. So therefore the intersection will be always non-empty. So there will be a common element in both the sets. So let us assume that say A1 equal to AI3. So let A1 equal to AI3. So therefore when you take AI3 minus A3, that will be equal to A1 minus A3. So which is even, since A1 and A2, sorry, A1 and A3 are of same parity. So we have taken A1, A2, A3 to be of same parity. So therefore when you take the difference A1 minus A3, ഒന്നെങ്കിൽ ഇത് രണ്ടും even ആണ്, അല്ലെങ്കിൽ ഇത് രണ്ടും odd ആണ്. So the difference is going to be even. So that implies one of the factors is even. So therefore AI1 minus A1, AI2 minus A2, so on AI5 minus A5 is always even. So that is the required proof. So let us look at another problem. So the next problem is 10 players took part in a round robin chess tournament. That is, each player must play exactly one game against every other player. Now, according to the rules, the player scores 1 point if he wins a game, -1 if he loses, and 0 point if game ends in a draw. When the tournament is over, it was found that more than 70% of the games ended in draw. Now we need to show that there were 2 players who had the same total score. So there are 10 players and the tournament is such that each player must play against every other player exactly once. He'll score 1 point if he wins, scores -1 point if he loses, and 0 if it is draw. ഇനിയും പറഞ്ഞിരിക്കുന്നതാണ് more than 70% of the games ended in draw. Now we need to show that there are two players who had the same total score. So let us see how to apply pigeonhole principle in this problem. Okay. Now let us first look at the given information. So it is given that each player can play another one exactly once. So if there are total 10 players, so there will be a total of 10 C2 games which will be played. Karanam, you will have to choose 2 at a time. So this can be, so the number of times, the number of games in the tournament will be 10C2. So since every players played one and only one game against each other, so there are only 10C2, so 10C2 will be 10 factorial by 8 factorial into 2 factorial, so that is 45 games held in the tournament. Now it is given that adinte agathu ee 45 il 70% draw aanu. Appo draw alladavan chance ulla games എത്രയാണെന്ന് നോക്കുക. Okay, so among this at least 70% of the games ended in draw. So when you take 70% of 45, that will be, so let us take the integer function corresponding to that, so you will get 31.5, so that is approximately 32. So therefore 32, at least 32 games ended in a draw, so there are at most 45 minus 32 games which did not end in a draw. Okay, കാരണം draw ആയി കഴിഞ്ഞാൽ അവിടെ points 0 ആയിരിക്കും. So there are 13 games which did not end in a draw. So that is at most 13 games which did not end in a draw. So there are at most 45 minus 32, so that is equal to 13 games which did not end in a draw. Now we need to prove that there are two players who had the same total score. Now let us assume contrary that none of the no players are having the same total score. So we need to show that there were two players with same total score